Hi students, in our previous video we were talking about the topic that is increasing and the decreasing function. So when we are talking about the increasing and decreasing function, we came across when we are saying a function it is an increasing function, when we are saying a function is an decreasing function. By using a first order derivative, how we are going to detect whether the given function is increasing or decreasing. So all these concepts we have already covered in our previous video. So now let us move to the exercise 6.2 regarding the based upon the increasing and the decreasing function. So in that first question, let us show that the function given by f of x is equal to 3x plus 17 is strictly increasing. So we need to show that the given function f of x, it is a strictly increasing function. So when we are saying a given function is strictly increasing, when f dash of x it is strictly greater than 0 means then we are saying the function is an strictly increasing function. So what is the given function here? That is f of x is equal to 3x plus 17. So this is the given function. So if I take the derivative of that one, that is the first order derivative, what is the f dash of x here? F dash of x it is 3, which is strictly greater than 0. So f dash it is strictly greater than 0 means what does that implies? The given function f of x, it is a strictly increasing function. So that's what we need to do, or we need to check whether the given function is strictly increasing, or we need to show that itself. So we have proved it by the first order derivative test. So similarly there is a second question, that is we need to show that the given function f of x is equal to e to the power 2x is also a strictly increasing function. So given function, what is that? F of x is equal to e to the power 2x. To say the when we say a function is strictly increasing, when f dash of x it is strictly greater than 0. So what is the f dash of x here? It is nothing but 2 into e to the power 2x. So exponential value, since the function is defined on the set of real numbers, we need to check for what value. So if you take any, for any x which is belonging to the set of real numbers, e to the power 2x, it will be always positive. So when positive term is multiplied with a positive number means we are going to get what? We are going to get a positive thing itself. So what does that implies? So f dash of x, it is strictly greater than 0. So f dash of x is strictly greater than 0 means what does that implies? The function f of x, it is strictly increasing. So that is what we needed to be proved, and hence proved. The next question, what is that? We need to show that the function which is given by f of x is equal to sin x, it is strictly increasing in the interval 0 to pi by 2, strictly decreasing in the interval pi by 2 to pi, neither increasing nor decreasing on the interval 0 to pi. So in my previous video I have discussed regarding like this type of function when f of x is equal to cos x, and generally I have explained how it is implied for sin x also by taking one of the general example. So the most of the basic things of sin x I have already explained in my previous video. So using that as a hint, I hope you can solve this question by yourself. So the third question I am leaving it for yourself to do it by yourself. So take this one as your homework and complete this third question. So the next question is, find the interval in which the function f, that is given by f of x is equal to 2x square minus 3x. So we need to check in which interval this function is strictly increasing and in which interval the function is strictly decreasing. So to solve this type of question, we used to have two steps. First, I am writing the given. What is that? F of x is equal to 2x square minus 3x. What is the first step we are going to do? We are going to take f dash, find what is f dash of x. So what is the f dash of x here? 4x minus 3. So this is our f dash of x. Then what we are taking, f dash of x is equal to 0. So if I input f dash of x is equal to 0 means what happens? 4x minus 3 is equal to 0. What does this implies? X is equal to 3 by 4. So at the point x is equal to 3 by 4, we are going to get its derivative, that is f dash of x is equal to 0. Suppose if I draw the number line, means what happens, this is minus infinity, this is point x is equal to 3 by 4 and this is the point infinity. So now we got two disjoint interval. What is that two disjoint interval? Minus infinity to 3 by 4. Another is 3 by 4 to infinity. So I am considering here open interval near the 3 by 4 because here they asked strictly increasing. If I consider the closed interval near 3 by 4 means what happens? At 3 by 4, x is equal to 3 by 4, we are going to get f dash of x is equal to 0. Then what happens in the given interval? We are going to get the function f dash of x, either it is less than or equal to or greater than or equal to, which is not required for us right now. Since we require strictly increasing and strictly decreasing, I am using the open bracket near the 3 by 4. Now let us check in which interval it is strictly increasing, strictly decreasing. So to check that one, we are randomly taking one point from this interval. So minus infinity to 3 by 4 means obviously we are going to get 0 within this interval. So I am substituting that value here when taking by x is equal to 0. What happens? F dash of 0 is equal to minus 3, which is less than 0. So minus 3 which is less than 0 means what happens here? F dash of x is less than 0 in the interval minus infinity to 3 by 4. So what happens? Strictly decreasing in which interval? Minus infinity to 3 by 4. Now let us check what happens from 3 by 4 to infinity. So from 3 by 4 to infinity, I am taking one random point, say x is equal to 1. What happens? F dash of 1 is equal to 4 into 1 minus 3, which is equal to 1, which is greater than 0. So in the interval 3 by 4 to infinity, we are going to get what? F dash of x, which is strictly greater than 0. So in this interval, that is 3 by 4 to infinity, the given function is strictly increasing. So this is how we are going to determine in which interval the function is strictly increasing and in which interval the function is strictly decreasing. So please pause the video and note it down. So let us move to the next question. Find the interval in which the function f, which is given by how? F of x is equal to 2x cube minus 3x square minus 36x plus 7. So when the function is given like this, so they are asking in which interval the function is strictly increasing and in which interval the function is strictly decreasing. So first step, what is that? I am finding the f dash of x. So given f of x is here itself, so I am taking f dash of x. What happens? 6x square minus 6x minus 36. So I am simplifying this one, taking 6 common outside. What I am going to get? Minus x square minus x minus 6. So if I factorize this one, what I am going to get? 6 into x minus 3 into x plus 2. So now what I have got? F dash of x is equal to 6 into x minus 3 into x plus 2. So this is our f dash of x. Now next step, what? I am taking f dash of x is equal to 0 and checking at which critical point we are going to get upon the number line. So if I take f dash of x is equal to 0, what happens? 6 into x minus 3 into x plus 2, this will be equal to 0. If this is equal to 0 means what does that implies? X minus 3 is equal to 0 or x plus 2 is equal to 0. So what we are going to get? The value of x is equal to 3 and value of x is equal to minus 2. So we got two critical points. So if I draw the number line and plot these 2 points, means minus 2, 3, plus infinity, minus infinity. So now we got 3 disjoint intervals. What are those 3 disjoint intervals? Minus infinity to minus 2, minus 2 to 3 and 3 to infinity. So we got these 3 disjoint intervals. Now let us check what is the sign of the f dash of x. What is the sign of f dash of x in these intervals? Okay, so to check what is the sign of f dash of x in these intervals, so why I am required the sign of f dash of x? So when I know the sign of f dash of x, that is whether f dash of x in the given interval it is greater than or 0 or less than or equal to less than 0 means at that time I can determine whether in the given interval whether the function is increasing or decreasing. So to determine whether the function is increasing or decreasing, I need to know whether f dash is greater than 0 or less than 0. So to know this one, I need to know what is the sign of the f dash of x in the given interval. So first thing, minus infinity to minus 2. So when I am talking about minus infinity to minus 2 means I am taking the point say minus 3. What happens to our f dash of x? Minus 3 minus 3. What happens here? Minus 3 minus 3, it is minus 6. So value is negative. What happens here? Minus 3 plus 2. Minus 3 plus 2, it is minus 1, again negative. So this one always positive. So negative into negative, what we are going to get? We are going to get positive. So what is the sign of f dash of x? It is positive. So sign of f dash of x is positive means what is that implies? F dash of x is greater than 0. It is greater than 0 means what is the nature of the curve then? The nature of the curve is what? It is strictly increasing. Similarly, minus 2 to 3. So when I am talking about minus 2 to 3 interval, 0 is lying within this interval. So if I take x is equal to 0, what happens here? 0 into 0 minus 3 is minus 3, which is less than 0. So it is negative. 0 plus 2 plus 2, it is positive. So we got negative into positive. Minus into plus, it is what? Always minus. So what we got? The sign of f dash is minus. So sign of f dash is negative means what does that implies? F dash of x is less than 0. When f dash of x is less than 0 means what does that implies? It is strictly decreasing curve. Similarly, 3 to infinity. So when I am talking about the interval 3 to infinity, if I take any point, say 4, what happens? 4 minus 3 is what? 1. So 1, it is greater than 0. So it is positive. So here 4 plus 2, it is 6. Again it is greater than 0. So it is positive. So positive into positive is always positive. So what is that? The sign of f dash is positive. What is the nature of curve? It is strictly increasing. So now in which interval the function is strictly increasing? The function is strictly increasing in the interval minus infinity to minus 2 union 3 to infinity. Upon this interval the function is strictly increasing. Upon which interval the function is strictly decreasing? The function is decreasing in the interval minus 2 to 3. So in this interval the function is strictly decreasing. Suppose if in the question they have asked only about what is the find the interval in which the function is increasing or decreasing. If they didn't mention strictly means how the interval will be, at that time we used to closed not open interval at minus 2, we used to have closed interval at minus 2 and closed interval at these places. So if I take closed interval means what happens? Minus 2 and 3 are included within that interval. When they are included within that interval at minus 2 and at x is equal to 3, we are going to get f dash of x is equal to 0. So when f dash of x is equal to 0 means what happens? At that time we are going to get, if I suppose minus infinity to minus 2 where 2 is included means what happens to the nature of the curve? F dash of x, it is what? It is greater than or equal to 0, because from minus infinity to minus 2 it is strictly greater, but at x is equal to minus 2 it is equal to 0. So the nature of the curve will be what? It is greater than or equal to 0. So greater than or equal to 0 means what happens? The function is an increasing curve. So this is how we are going to deal with the interval when depending upon what they have asked to find us. So this is regarding the fifth question. So pause the video and note it down. So now let us move to the next question. That is, we need to find the interval in which the following functions are strictly increasing or decreasing. So they have given certain functions already. So we need to check in the particular function at which interval the function is increasing or decreasing. So I am telling in the beginning itself, I am leaving this first one and this one as for yourself to do it as a homework. Okay. So in your NCERT textbook, this is the A and this is I think D. This is the D in your NCERT textbook. So I am leaving these two for you peoples only to do it as a homework. So let us see it for the second one, that is when f of x it is equal to 10 minus 6x minus 2x square. So what the first thing we are going to do, I am taking the derivative of the given function. So what is the derivative of the given function? Minus 6 minus 4x. So this is the derivative of the given function. Now what is my next step? If I take f dash of x is equal to 0, means what happens? Minus 6 minus 4x, it will be equal to 0. So what does that implies? Minus 4x is equal to 6. So value of x, it is what? 6 minus 6 by 4, it is nothing but minus 3 by 2. So I got the critical point. If I plot it on the number line, means what? At x is equal to minus 3 by 2. So we got what? We got now two disjoint interval. What is that? Minus infinity to minus 3 by 2. Another one is minus 3 by 2 to infinity. So we got two disjoint intervals. So now we need to say in which interval the function is strictly increasing and function is strictly decreasing. So minus infinity to minus 3 by 2. So minus 3 by 2 means what point you might think? It is nothing but minus 1.5. So you should take the point which is lying from minus infinity to minus 1.5. So what I am taking the point is, if I take x is equal to minus 2. So when I take x is equal to minus 2, that point is lying in this interval. So what happens to our f dash of x? F dash of x is what? That is minus 6 minus 4x. So minus 2 means minus 6 minus 4 into minus 2. So what happens? Minus 6 minus 4 2s are 8, minus into minus it becomes plus. So we are going to get 2 which is greater than 0. So if you take the values anything between minus infinity to minus 3 by 2, means in this interval minus infinity to minus 3 by 2, our function, that is f dash of x, it is greater than 0. So when f dash of x it is strictly greater than 0, means what does that implies? Our function f of x, it is strictly increasing. Similarly, now I am taking a point in the interval minus 3 by 2 to infinity. So here I am taking the value x is equal to 2. What happens? Or you can take x is equal to 0 itself, because even 0 is also lying within this interval now, not in this interval. So what happens if I take x is equal to 0, means f dash of x is equal to minus 6 minus 4x. If I take x is equal to 0, value of f dash of x, it is minus 6, which is less than 0. So when f dash of x is less than 0, means what happens now here? The function f of x, it is strictly decreasing. So in which interval I have taken this one? The interval I have considered here is minus 3 by 2 to infinity. So in the interval minus 3 by 2 to infinity, the function is strictly decreasing. So in this interval, the function is strictly increasing. So we got the interval in which this function is strictly increasing and strictly decreasing. So pause the video and note it down and then move to the next question. So the next question is f of x is equal to minus 2x cube minus 9x square minus 12x plus 1. So first thing what I am doing, I am taking the derivative of this one. So what is the derivative of this one? Minus 3 2s are 6 minus 6x square minus 9 2s are 18x minus 12. So this is the derivative of the given function. So if I take minus 6 common outside from this one, what is remaining? X square plus 3x plus 2. So this is remaining. So if I factorize this one, so what happens? Minus 6 x plus 1 into x plus 2. So this is the factorization of x square plus 3x plus 2. So x plus 1 into x plus 2. So this is what we got as what? F dash of x. Now if I take f dash of x is equal to 0, means what happens? Minus 6 x plus 1 into x plus 2, this will be equal to 0. When this will be equal to 0, what happens? Either x plus 1 is equal to 0 or x plus 2 is equal to 0. So this gives the value for x, that is x is equal to minus 1 and x is equal to minus 2. So now we got here two critical points when f dash of x is equal to 0. So what happens if I plot this point on the number line? If this is minus infinity and this is plus infinity, what happens? Minus 1, minus 2. So now here what we got? We got three disjoint interval. What is that? Minus infinity to minus 2, minus 2 to minus 1 and minus 1 to plus infinity. So these are the three disjoint intervals. Now we need to check in which interval the function is increasing and function is decreasing. To say whether the function is increasing or decreasing, we should know whether what is the sign of f dash of x, whether it is greater than 0 or f dash of x it is strictly less than 0. So let us find what is the sign of f dash of x. So for that one, first I am considering in the interval minus infinity to minus 2. So in this interval I am considering one point, say minus 3. So what happens? Minus 3 plus 1, it is minus 2. So first thing, it is positive, not positive, it is negative. Remember here we are having minus 6. So obviously that is also negative. It will be always negative. Here if I input x is equal to minus 3, what happens? Minus 3 plus 1, it is minus 2. Again negative. Here I again input minus 3, means what happens? Minus 3 plus 2, it is minus 1, again negative. So what happens? Minus into minus plus, plus into minus is again minus. So what happens? The sign of f dash, it is negative. F dash is negative means what is that implying? F dash of x is less than 0. So what happens to the nature of the curve? Here f dash of x is less than 0 means what implies? That implies function is strictly decreasing. Similarly, minus 6, obviously it is negative. X plus 1, so the interval it is lying from minus 2 to minus 1, where minus 2 and minus 1 are completely excluded here. So taking any point which is lying between minus 2 to minus 1, I am taking minus 1.5. So what happens? Minus 1.5 plus 1 means it is again negative. Minus 0.5, we are going to get value negative. Again here minus 1.5 plus 2. So minus 1.5 means what happens? Minus 1.5 plus 2 means here it is a positive value, that is plus 0.5. So we are going to get positive value. What happens here? Minus into minus, plus, plus into plus, again plus. So the sign of f dash is positive means what does that implies? F dash of x is greater than 0. So f dash of x is greater than, strictly greater than 0 means what implies? The function is strictly increasing. Similarly, from minus 1 to minus infinity. So 0 is lying in this interval, so I will easily go with 0. So if first thing, minus 6, obviously it is negative. If I input x is equal to 0, what happens? 0 plus 1 plus 1, which is positive. 0 plus 2 plus 2, again it is a positive. What happens? Minus into plus, minus, minus into plus, again minus. So what we are going to get? We are going to get negative. So f dash, sign of f dash is negative means what does that implies? F dash of x is less than 0. Less than 0 means what happens? It is strictly decreasing. So now in which interval the function is strictly increasing? The function is strictly increasing in which interval? In the interval minus 2 to minus 1. And strictly decreasing in which interval? Strictly decreasing in the interval minus infinity to minus 2 union minus 1 to infinity. So upon these interval the function is strictly decreasing, upon this interval the function is strictly increasing. So this is how we are finding the interval in which the function is strictly increasing and strictly decreasing. So pause the video and note it down. The next question, that is x plus 1 whole cube into x minus 3 whole cube. So this is our f of x. So what is the first thing we need to find out? We need to find what is f dash of x. So clearly it is the product of two function. I can use the product rule. So what is that product rule? First function, that is x plus 1 whole cube as it is, differentiation of the second function. So what is the differentiation of that one? 3 into x minus 3 whole square into differentiation of x with respect to x, it is 1, plus second function, what is that? X minus 3 whole cube into differentiation of the first function. What is the differentiation of the first function? 3 into x plus 1 whole square into differentiation of x with respect to x, it is 1. So this is what we got after differentiating this one. So now in these two terms, what is common lying over here? The common terms which are lying over here are x plus 1 whole square. So x plus 1 whole square into, then which one? X minus 3 whole square. So I am not taking the numbers outside right now. So after taking x plus 1 whole square into x minus 3 whole square, what is left out in the first term? In the first term, this term is completely came out. From here only x plus 1 whole square came. So the remaining is 3 into x plus 1. From the second term, this term is completely came out. 3 is left as it is. From this term only x minus 3 whole square has came out. What is remaining? X minus 3. Now what happens here? X plus 1 whole square into x minus 3 whole square. Here 3x plus 3 plus 3x minus 9. So what happens? 3x plus 3x, it is nothing but 6x. 3 minus 9, it is nothing but minus 6. So from here I can take 6 common outside. So what is remaining then? X plus 1 whole square, x minus 3 whole square, here x minus 1. So what is this? This is our f dash of x. I got what is f dash of x right now. After that one, we need to find the critical point. To find the critical point, I am taking f dash of x is equal to 0. When I take f dash of x is equal to 0, what does that imply? 6 into x plus 1 whole square into x minus 3 whole square into x minus 1 is equal to 0. When the product of term is equal to 0 means what does that implies? Either x plus 1 whole square is equal to 0 or x minus 3 whole square is equal to 0 or x minus 1 is equal to 0. If this one is equal to 0 means what is the value of x I am going to get? Moving this square to the RHS, it will become 0 itself. So value of x here we are going to get minus 1. Here from this I am going to get the value of x is equal to 3. From here I am going to get the value of x is equal to 1. Now we got 3 critical points when I substitute f dash of x is equal to 0. So now if I plot all these points upon the number line means what happens? From minus infinity to infinity, x is equal to minus 1, it will lie somewhere here. X is equal to 1, it will lie somewhere here, and x is equal to 3, it will lie somewhere here. So now how many disjoint intervals we got here? We got here minus infinity to minus 1, 1 disjoint interval. Next minus 1 to 1, another disjoint interval. 1 to 3, another disjoint interval. Then next 3 to infinity. So we got 4 disjoint intervals. Now we need to say in which interval the function is strictly increasing and strictly decreasing. So to know in which interval, first thing what we need to know what is the sign of f dash of x. So to know the sign of f dash of x, what we are dealing, we know what is f dash of x here. Let us input one value which is coming under in respect to intervals and guess whether the function is increasing or decreasing. So 6 here, it is obviously positive, whatever, it doesn't changes. Suppose from minus infinity to minus 2, if I take whatever value from here we are having square. If it comes negative, square of negative is always positive. So here since we are having square, obviously the first term whatever be the value of x, it is always positive. Similarly in the case of second one also, whatever might be the value, irrespective of from which interval I am taking the value of x, irrespective of that one, since we are having square, the whatever the terms we are going to get from this second term, it is also always positive. It is only depending upon this third component, whether if it is positive means then the function is increasing, suppose if it is negative means then the function is decreasing, because all the three are positive in all the cases, because this is obviously positive, and from the first two terms, what, since we are having the square, whatever the value of x, it will be always positive itself. So what happens, from minus infinity to minus 1, I am taking the value minus 2. What happens, minus 2 minus 1, it is minus 3. So minus 3, it is less than 0. So it is negative. So now what happens, positive into positive, positive, positive into negative is negative. So we got what, sign of f dash of x is negative. What does that implies, f dash of x is less than 0. When f dash of x is less than 0 means what implies, the function is strictly decreasing. Similarly, for the next one, that is from minus 1 to 1. So again 6, it is always positive. So as it is, whatever be the value, the first term, this one is also positive. Whatever be the value of x, this one is also positive. Now minus 1 to 1. So minus 1 to 1, obviously our hero of the number line, that is 0, is lying there. So I am taking with the 0 itself. If I substitute x is equal to 0, what is the value, minus 1, which is less than 0, so it becomes negative. So what is the sign of f dash of x, positive into positive, positive, positive into negative is negative. So the sign of f dash of x is negative. So what happens when f dash, sign of f dash is negative means f dash of x is less than 0. It is less than 0 means what does that implies, the function is strictly decreasing. Similarly, from 1 to 3. So from 1 to 3, obviously 6 is positive, positive itself, x plus 1 whole square, irrespective of the value. First term and the second term, they both are positive. I mean the first factor and the second factor. The next factor, from 1 to 2, if I take the value, say 2 means what happens, 2 minus 1, it is 1, again positive. So what happens, positive into positive, positive, positive into positive, again positive. So what is that, f dash of x, it is greater than 0. So what if f dash of x is greater than 0 means the function is strictly increasing. Similarly, 3 to infinity. So first two factors are positive. Whatever the value from 3, 4 means 4 minus 1, it is also positive. What happens, positive itself. So all are positive means the sign of f dash of x is also positive. It is positive means f dash of x, it is greater than 0. It is greater than 0 means what, the function is strictly increasing. So from which interval to each interval the functions are strictly increasing? The functions are strictly increasing in the interval 1 to 3 union 3 to infinity, and the functions are strictly decreasing in the interval minus infinity to minus 1 union minus 1 to 1. In this interval the function is strictly decreasing. In this interval the function is strictly increasing. So now let us move to the next question, that is we need to find the, what we need to show here, show that y is equal to log of 1 plus x minus 2x divided by 2 plus x, where x is strictly greater than minus 1, is an increasing function of x throughout its domain. So what they are saying, in the defined domain the function is a strictly increasing function. So we need to show that one. So when we need to they are saying we need to, so they are saying increasing function. So what is the domain here? So clearly the domain is what, the domain of the given function is x is greater than minus 1, that is from minus 1 from minus 1 to infinity. This is the domain of the given function. So what is the given function? Y is equal to log of 1 plus x minus 2x divided by 2 plus x. So this is the function. So what is the first thing we need to do? Y is nothing but f of x. So what is the first thing we need to do? We need to find f dash of x. So f dash of x is nothing but what here? Dy by dx. So dy by dx means what happens? What is the differentiation of log of 1 plus x? It is 1 divided by 1 plus x minus 2 into differentiation of x divided by 2 plus x. So we can differentiate this one by the quotient rule. So what happens? 1 divided by 1 plus x minus 2 using the quotient rule, second function square into second function into differentiation of the first function. Differentiation of x with respect to x is 1 minus first function differentiation of the second function. Differentiation of 2 with respect to x is 0. Differentiation of x with respect to x, it is 1. So we got the differentiation of this one. So what is the thing? 1 divided by 1 plus x minus 2 into 2 plus x minus x divided by 2 plus x whole square. So what happens here? Plus x minus x get cancels. So the remaining is 1 divided by 1 plus x minus 2 plus 2, it is nothing but minus 4 divided by 2 plus x whole square. So if I take the LCM, means what happens? 1 plus x into 2 plus x whole square. Here for the first term, 2 plus x whole square minus 4 into 1 plus x. So now let us simplify this one, the 2 in the numerator, that is 2 plus x whole square minus 4 into 1 plus x. So if I simplify this one, what I am going to get here using the identity, 4 plus x square plus 4x minus 4 minus 4x. So minus 4 plus 4 get cancels, minus 4x plus 4x get cancelled. So the remaining is x square divided by 1 plus x into 2 plus x whole square. What is this? This is our f dash of x. So in which domain they have defined? So f dash of x for all x which is greater than minus 1. Now what we need to show? We need to show that the given function is an increasing function. Observe here clearly, x square and 2 plus x whole square. For whatever might be the value within this domain, that is for x which is greater than minus 1, if I take whatever value of x might be, these two values, that is x square and 2 plus x square, it will be always greater than 0 itself. So there is no changes in that one. So whatever might be the value, it will be obviously strictly greater than 0. Then the thing remaining is what? Here 1 plus x. So if I take 1 plus x, whatever might be the value lying in this interval, in this domain for all x greater than minus 1. If you take any value which are strictly greater than minus 1, means what happens here? Whatever the values for all x greater than minus 1, 1 plus x, it is also strictly greater than 0. So now what happens here? Being a perfect square, these are greater than 0. Being since they only defined the domain for x which is greater than minus 1, even this term is also greater than 0. Now you can see our f dash of x, this one is also greater than 0, this one is also greater than 0, even this one is also greater than 0. What does that implies here? F dash of x is greater than or equal to 0 for all x which is greater than minus 1. So f dash of x is greater than or equal to 0 means what implies? The function is an what? F of x, it is an increasing function. What they said? They didn't only said it is an increasing function of x throughout its domain. So what was the domain defined here? X is greater than minus 1. So for all x greater than minus 1, f dash of x is greater than 0 means what does that implies? The function f of x is an increasing function throughout its domain. So this is what they have asked us to prove and we have proved it. So this is how we are going to deal with the question. So pause the video and note it down. The next question is, find the value of x for which y is equal to x into x minus 2 whole square is an increasing function. So we need to find the value of x for which the function is an increasing function. So what is the given function here? That is y is equal to x into x minus 2 whole square. So this is nothing but our f of x. So we need to show in which value the function is an increasing function. So what happens that if I simplify the brackets first, means x square minus 2x whole square. So x square minus 2x whole square, this is our y, or this is our equal to f of x. First thing is we are finding the differentiating this f of x. So f dash of x is nothing but dy by dx. So what is the differentiation of this one? So it is nothing but 2 into x square minus 2x by the chain rule, differentiation of x square minus 2x. So what happens? 2 into x square minus 2x, differentiation of x square is again 2x, differentiation of minus 2x is minus 2. Now let us simplify this one. So what happens when I am simplifying this one? From this one I can take 2 common outside. 2 into 2 it becomes 4. X square minus 2x into x minus 1. Even from here also I can take the x common outside. 4x into x minus 2 into x minus 1. So this is our f dash of x, or dy by dx. So now we got the function. So to check in which for what values we are going to get the function is an increasing function, means in which value we are going to get, means what happens. So we are thinking about in which interval or in which for which values. So first thing what I am doing, I am substituting f dash of x is equal to 0 here. So when I substitute f dash of x is equal to 0, what implies that 4x into x minus 2 into x minus 1, this will be equal to 0. This implies either x is equal to 0 or x minus 2 is equal to 0 or x minus 1 is equal to 0. So this implies x is equal to 0, x is equal to 2, x is equal to minus 1. So we got 3 critical point, that is x is equal to 0, x is equal to 2 and x is equal to 1. So now if I plot this one on the number line, minus infinity to plus infinity, x is equal to 0, 1, 2. So we got 4 disjoint interval, minus infinity to 0, 0 to 1, 1 to 2 and 2 to infinity. So what happens? Let us see what is the sign of f dash in all these 3 intervals. So what happens from minus infinity to 0? So if I take any value between minus infinity to 0, say minus 1, if I take that value as equal to minus 1. So what happens? Minus 1 means the sign of this one, 4, it will be obviously positive. If x value is equal to minus 1 means this term, the sign of x, it is negative. What is the sign of here? X minus 2, minus 1 minus 2, it will become minus 3, again negative. What is the sign of this one? Minus 1, or we can't take minus 1 minus 1, it will be minus 2. So it becomes what? Minus into minus into minus. So what happens? Minus into minus plus, plus into minus, it is minus. So sign of f dash of x, it is negative. So sign of f dash of x is negative means f dash of x, it is less than 0. The function is strictly decreasing. Similarly from 0 to 1, if I take any point from 0 to 1, say 0.5. So I am taking which point here? 0.5. What happens? 0.5, it is positive. The sign of x, it is positive. 0.5 minus 2. What happens? 0.5 minus 2, it will be minus 1.5. It will be negative. What is the sign of here? 0.5 minus 1, it is minus 0.5, again negative. What happens? Positive into negative, negative, negative into negative, it will be positive. So what happens? The sign of f dash, it is negative means f dash of x, it is greater than 0. The function is what? The function is strictly increasing. Similarly from 1 to 2. So from 1 to 2 I am taking the point, say 1.5. What happens? Sign of x, it will be positive. Sign of x minus 2, 1.5 minus 2, it will be minus. 1.5 minus 1, it is 0.5, it will be positive. What happens? Positive into negative, negative, negative into positive, again negative. So sign of f dash is negative means f dash of x, it is less than 0. The function is what? It is strictly decreasing. Now my 2 to infinity. So from 2 to infinity I am taking the point say 3 means what happens? Sin of x, it is positive. Sin of x minus 2. So 3 minus 2, it is 1, again positive. Sin of x minus 3, 3 minus 1, again positive. Positive into positive into positive, again positive. So sin of f dash of x, it is greater than 0. So function, it will be strictly increasing. What was the question they asked? We need to find the value of x for which our y it is an increasing function. So increasing function means for which intervals and all we got function as an increasing from 0 to 1 and from 2 to infinity. So if union of this one will be giving us what? The function in these intervals or for these values of x, the function is strictly increasing. So this is how we are dealing with the problems on finding whether how the function is increasing or decreasing in the interval. So since here they asked only about the increasing function, I am mentioning only that one. Upon this interval the function is strictly increasing. So pause the video and note it down and go through each and every problem step by step. Suppose if you have any doubts regarding any of the question, you can ask me at any time. Thank you, students.